All right, so we are going to do arc length today. So arc length of parametric equations. So we did this with rectangular equations, and I'm going to bring up that formula. And this is kind of a thing where you sort of just memorize the formula and then off you go. But it is cool because it's like, you think about motion where your particle starts out and then where it ends up, you're figuring out how far it went. And it's cool because, like, if you go in a straight line, that's simple. That's an algebra thing. You just find the distance. But say your particle travels like this. It's cool to be able to find that actual length, like that we can do that. I just think that's neat that we have the ability to do that. So I'm going to remind you of the rectangular version of this. And again, remember, rectangular is like y in terms of x or x in terms of y. It's the name for what you've always done. We've just never told you it's called rectangular because you never did parametric or anything different. It was integral a to b. And does anyone like remember any part of it or like what it sort of looked like? It was a couple units ago, so I'm not expecting a whole lot, but I just want to see it. It what? It's not a fraction. There's a gigantic square root.
Oh, that 1 plus.
Oh, good. Oh, good. Teamwork. Okay. 1 plus derivative squared dx. And it is pretty much the same thing for this with like one alteration. All right. So for parametric, let me write it first, and then I'll show you how it actually is like meaning the same thing. So you go from a to b, gigantic square root. So here's like the slight difference. Instead of in terms of x, it's in terms of t, and that's because both x and y are in terms of t. But if you look, it's the same thing. Like this is y of t squared, and if you think of f of x being y, that's the same thing. It's just here you have an x that's in terms of t as well. The reason this one is 1 is because when you're doing a derivative for rectangular, what's the derivative of x? 1. Like I could have written it as like that way squared as well, but it's just 1, so we just write 1. It's really the same thing just for parametric. Okay, we're literally just going to try a couple of these and that's the lesson. Okay, because there is not much to it. The biggest hurdle is going to be remembering how to do an antiderivative. Because setting it up, if you just memorize the formula, setting it up's not bad. So this is going to be integral -1 to 3. Like they literally just hand it to you. Like those are your boundaries. Gigantic square root. And here's my suggestion. Write it out blank. And that's what I said when we did the rectangular version too. I wrote 1 plus blank squared. Write blank squared plus blank squared dt. Because then you can just go and fill it in, and then you don't get lost with like the formatting, so to speak. You have it set up. You're just going to go back and fill in the blanks. So this is going to be the derivative of x. This is going to be the derivative of y. So here we go. What's the derivative for x? 3. We're starting out with an easy one. Derivative for y? -2. And then you can sort your way through that, but set up like the framework of it first. So this will be integral -1 to 3. And let's see what we have under that square root. It'll actually just be a number, right? 3 squared, 9, -2 squared, 4, 9 plus 4, 13. I know it looks weird because it's a square root, but like pretend it's not a square root for a second. What would be the antiderivative for just 13? It'd be well, in this case, it's going to be 13t. But if there's a square root there, then your antiderivative is square root of 13t. Like it's just a number. It's an irrational number. It's got a square root in it. And then we're going to do upper boundary minus lower boundary, and that'll be our answer. So plugging in the upper boundary, it'll be 3 square root of 13. Lower boundary will be -1 square root of 13. And if we're being really particular, like pretend it was multiple choice, they're not going to leave it like that. You would have to put it all together. What would you get? Yeah, good, because these negatives are gonna cancel, you're gonna add it together, so 4 square root of 13. And that's the length of that curve in whatever units, you know, I didn't give you inches or feet or whatever, from -1 to 3. Cool, it's cool. Neat, guys. Let's try another one. Make this one a little bit tougher. Because I believe in you. So set up your framework. It'll be integral 1 to 4 gigantic square root blank squared plus blank squared dt. Just set it up with the blanks and then you can go back and fill it in. Like have the skeleton of the problem. So this is derivative of x, this is derivative of y. So what's going to be our derivative for x? 12t. And then derivative for y, 6t squared. And then from there, you can clean that up and, you know, do as many more steps as you need to, but like set it up with the blanks first. And again, usually on the AP exam for free response stuff, you get a point for the setup. So like always just do that first. So let's see what we've got underneath the square root. What do you think? Careful. 144 t squared plus, good, careful with the exponent there, 36t to the 4th. Now you can't combine those together because they're not like terms, but you can factor them. What do they have in common that we could factor out? Bigger than 6. Bigger than 12. 36. You still have those calculators out? Do 144 divided by 36. I think it comes out to a whole number, doesn't it? Isn't it 4? What else can you take out? What else do they have? This is GCF. What else do they have in common there? T squared. So we're going to take that out and see what's left. So it would be 4 plus t squared. And you're like, where is she going with this? Sometimes you don't really know. Sometimes you kind of just look at what you have. And if you're like, well, if I can't combine those together, maybe I'll try to factor something out. Now, look at what you have. What do you notice about the number 36? Like, why is that a convenient or like a good number to have? You can square, good. What is your square root of 36? Be 6. Square root of t squared would just be t. Okay, so I'm going to rewrite it as 6t out front. And then square root, can I write t squared plus 4? Is that okay? Instead of 4 plus t squared. Does anybody else like the variable to come first? I don't know, that's just like my brain is happier with it that way. All right, now we're ready to start trying to think about doing an antiderivative. I've got it as simplified as I can, and guess how we're going to do this antiderivative, guys? It is a U substitution, but let me answer this question first. Go ahead. No, because there's no cancellation without factorization. It won't cancel. I promise. It mathematically does not work. You can't cancel these separately because it's a t squared plus 4. And if you want to put parentheses around it to remind you, you cannot separate those out. I know everybody always wants to do that, but you can't. This one we could do because we factored it out. So what are we going to let u equal? It is going to be a u substitution. What did you say? Yep. T squared plus 4. And then what's that derivative? 2t dt. And then you want to compare that to what's in the problem. I don't see a 2t, but I do see 6t. So we're going to adjust with a 3. So then when you go to substitute, 3 goes out front, du goes at the end. What's still there? We substituted for the 6t, so that's taken care of. Square root of u, which I'm going to write as u to the 1/2. Beautiful. Why didn't I write the boundaries 1 to 4? You got to adjust them. Plug in 1 right here. That'd be 5. plug in 4, is that 20? And then do the antiderivative. I'll be really honest, doing the antiderivative is the step that a lot of people skip, and I get why it happens, because you feel like you've already done a lot of work, but everything we've done so far is like factoring and simplifying and like a whole bunch of algebra, and then we wrote out these steps, but you still have to do the antiderivative, okay? So you have to add 1 to the power. 3/2, and that means out front 2/3, such that 5 to 20. And this is actually kind of convenient. I know there's nothing convenient about this, and we hate you, Miss Cole. But what is going to cancel here? The 3's will cancel, and we're just going to do upper boundary minus lower boundary, and I'll let you just leave it alone here because it's not really going to simplify any better than it looks now. So 2 times 20 to the 3/2 minus 2 times 5 to the 3/2, whatever that is. But that's some number. If you could type in a calculator, you would get some number, and that number represents the length of the curve from 1 to 4. Or you can think of that like a total distance traveled. Wink, wink, nudge, nudge. Bless you. I'm just trying to let you know where we're headed. You remember velocity, acceleration, displacement, total distance?
I don't know where we're going.
It's just where we're headed eventually with this, okay? I'm going to do 2 more, but we're just going to set them up. We won't actually like do the whole everything, okay? Because some of the ones in your homework just say set it up, but don't actually like evaluate it. So I'm just going to do a couple more where we just do the setup. So you set it up and you kind of simplify it down, but then just don't do the antiderivative. All right, so this will be integral 0 to pi, gigantic square root, and just set it up blank. Actually, these derivatives are going to be a little bit longer. Leave yourself like more of a blank for these ones. Let me extend this here. So this is going to be derivative of x. This is going to be derivative of y. So what do you think about derivative of x? All right, 2 cosine t. Oh my gosh, perfect. Why is it times negative sine? What rule is that? Chain. Good teamwork. Okay. Now we're going to do the same thing for the derivative for y. It'll be 5 sine to the 4th of t. Why did this one not have another number in there? Yeah, I mean, you could put 1 there if you want to. Times cosine. Perfect. Okay, good. And we're just going to do one more step of simplifying that down. Again, the reason I'm doing this is because in your homework, they did a couple like this where you just have to set it up. Now, you can actually dodge a bullet with these if you forget a negative. They're kind of forgiving like that. If you forget a negative sign, why won't it actually matter? You're squaring, it's going to be positive anyway. So honestly, if you forget a negative, you kind of end up with the right answer anyway. But anyway, squaring a negative, it's going to be positive what? 4 cosine squared sine squared plus, and then we're going to do the same thing for the other one. It would be what? Close. 25 sine. Do you remember how to do a power to a power? To the 8th, you would multiply those. Sine to the 8th of t cosine squared of t. Just as a heads up, when you get to something like that in your homework, all the choices are going to look the same. And you're going to have to look at these tiny little exponents and like really check them to make sure you don't pick the wrong one. All right, we're just going to do one more. Yeah, let's see how it went. So integral 1 to 7, gigantic square root, blank squared plus blank squared. So what is your derivative for x? What'd you put in this first one?
60 squared.
right? 6t squared plus 1, that's the one that's going to cause us a little bit of a headache. And then this one, just 8t, okay? So whenever you go to square that, it's 6t squared plus 1 times 6t squared plus 1.
Yeah, we don't.
So you're gonna have to distribute all that stuff to each other. I call it FOIL, first, outside, inside, last, but here we go. What will the firsts give you?
36 feet or 4.
Beautiful. The outsides will give you 6t squared, the insides will give you 6t squared, so all together. And then plus 1. 1 times 1 just gives you 1. All right, so that's the first part. So you have to multiply all that out. This one would be beautiful. And then I think there's one set of like terms there that we can put together. Yeah, these are going to go together. So 36t to the 4th, let me not do another copy error here. 36t to the 4th plus 76t squared plus 1, and then dc. And again, that was just the setup.